Alright, so in this video, again, we are doing a dilation, which is a transformation that produces a figure that is the same shape as the original, but not the same size. Okay, so this is just a continuation. I'm sorry my video got cut off, but this is just a continuation. So now we are on question 2. Question 2 says dilate triangle DEF by a scale factor of 1/2 from the origin. Alright, so here's triangle DEF, and I want it to be half as big, right? 1/2, so 1/2 as big, and 1/2 the distance as well from my origin. Okay, so the first thing I'm going to do is I'm going to figure out how I get to each point. So let's do point D right here. How did I get to point D from my center of dilation, which is my origin? If you're looking, it looks like I went over -16 and down -14. So to get to D, I went -16, -14. Okay. To get to E, I went over -16 and I went down -8. So E is at -16, -8. All right, and then F, to get to F, I went -8, -14. Right? Did you guys see that? Okay, so in the last video we said anytime you're doing it from the origin, you can just multiply by the scale factor. So because our scale factor is 1/2, I am just going to multiply my coordinates by 1/2. Okay, when you multiply by 1/2, it is the same as dividing by 2, right? I'm going to do a quick example down here to show you. So we're going to do 16 times 1/2, -16 times 1/2. If you do it on your calculator, -16 times 1/2 will tell you it's -8. -16 divided by 2 is also -8. So those are the exact same thing. You'll get the same answer. I'm going to say multiplying by 1/2 for purposes, though, of this video. But you could always just say it's dividing by 2 in this case because it's a unit fraction. All right, so 16 times 1/2 is -8. So I'm going to go back 8. And then -14 times 1/2 is -7. So I'm going to go 8, -7. Where those two meet, I am putting a dot. And that is now D prime. So D prime's coordinates are -8, -7. Okay. All right, now we're going to look at E. E is at -16, -8. So -16 times 1/2 is -8. -8 times 1/2 is -4. So I'm going to put a dot right there at -8, -4. And that is E prime. So E prime is at -8, -4. All right, and our last one is F prime. And F prime was at -8, -14. So 1/2 of, or 1/2 times -8, sorry, 1/2 of -8 is -4. So I'm going to go back -4 right here. And then -14 times 1/2 is -7. So right there at -4, -7 is F prime. I'm going to connect my triangle in blue. Ta-da! And I just did a dilation of DEF around the origin by 1/2. So you notice that it got half as big. Line DF is twice the size of D prime F prime. D prime F prime is half of DF. The distance to F prime is half the distance to F. Okay, so again, all I did, if it is around the origin, is you multiply your original coordinates by the scale factor. So you're multiplying by 1/2 in this instance to get my new coordinates. And then I just connected it. It is still a triangle. It is still the exact same shape, right? Same shape meaning my angles are the same. Let's look. Angle D right here is a 90-degree angle. D prime is still a 90-degree angle. Okay, the angles are still the same, and my sides are just proportional. So it's a similar shape in this case. Okay.